All right, here we go. This is video 4 in a series on solving higher order polynomial equations. Our focus is on factoring. Remember, these are polynomial equations that have an exponent greater than 2 in them. I hope you've watched the first video. If not, there's a link down below, because I go into great detail on these rules and steps and how you know if you've found all the solutions you need to. So make sure to give that a try. All right. This video focuses on what we call quadratic type, or often quadratic form, which are polynomials that behave like our regular x squareds. They factor nicely, they solve relatively easily, but they have different degrees or different exponents. So the first one we're going to look at, number 6, factors like a quadratic in x squared. So we set it equal to 0. Even if you didn't know this special pattern, you would want to set it equal to 0 anyways, because that's just generally how we treat polynomial equations. We almost always start by setting equal to 0. So I can factor this to 0 equals x squared minus 4 times x squared plus 3. If you don't believe me on that, check it out with the FOIL pattern to make sure that that multiplies back up to x to the 4th minus x squared minus 12. So I can set each of these factors equal to 0. I'm really excited about this factor on the left, because I know if I set 0 equal to x squared minus 4, that has some nice real number solutions, some nice integers. So from that one, I get x equals -2 and x equals +2. I know I'm searching for 4 solutions here, so I'm going to look at the other factor. Now, unfortunately, this isn't a difference of squares. In fact, it's not even a sum of squares. So I'm going to go ahead and I'm going to set 0 equal to x squared plus 3. Since this doesn't factor, I would bet the easiest way to solve this is by extracting square roots. So -3 equals x squared, or x equals plus or minus I root 3. So I've got 2 solutions there, positive I root 3 and negative I root 3. 4 solutions in total, 2 in the blue, now circled in green, and 2 in the green, now circled in blue. All right, moving on to the next problem. Why don't you pause the video here and give factoring problem number 7 a try. All right, pause the video. You ready? All right, so it's going to factor like this. Not really, you should try this yourself. If you haven't already tried, I think you should give it a go. I notice that I've got +8 here at the end, which means these must both be subtraction signs. And I notice this -17, which is really close to 2 times 8. So usually that gives me something like this. A -8 to multiply by the 2x squared, and a -1 to multiply by the x squared. So that's how this factors. And getting solutions out of this is as easy as setting those equal to 0 and solving. I'm going to solve by square roots again, because I think that's the easiest way for simple binomials like this. So I'm going to get x squared equals 1/2, and x squared equals 8. I notice I'm still on track for 4 solutions because I've broken it up into a quadratic and a quadratic. 4 solutions total. So I'm going to get x equals plus or minus the square root of 1/2, which if you're in calculus, that's probably an okay answer. If you're in geometry, that's definitely not an okay answer. So let's rationalize that. X equals plus or minus 1 over the square root of 2. Careful not to make a mistake here. X equals plus or minus root 2 over 2. So that's two solutions, positive root 2 over 2 and negative root 2 over 2. Moving on to the other side, I've got x squared equals 8, which means x equals plus or minus the square root of 8, or x equals plus or minus 2 root 2. All right, 4 solutions in total. Now, number 8 is kind of 2 different forms. Go ahead and try and factor it. You should notice something staring you right in the face. First, I noticed the 2. So 2 times x to the 4th minus 16. Now, teachers talk about these in a lot of different ways, but I view x to the 4th minus 16 as a difference of squares. I don't think of it so much as quadratic type, but it does fit that mold too. I can factor that to x squared plus 4 times x squared minus 4. Now, x squared minus 4 is going to factor really nicely. X squared minus 4 is something we factor all the time. X squared plus 4 doesn't factor over the real numbers at all. So I'm starting to see solutions come out of this already. I know that x equals negative 2 is going to be a solution, and x equals positive 2 is going to be a solution from those two sets of parentheses. So I need to set x squared plus 4 equal to 0. I think we've done this in these videos already. When I set x squared plus 4 equal to 0, I get x equals plus or minus 2i. So 4 solutions, plus or minus 2i, and positive or negative 2. This matches with the exponent of 4 that I was hoping for at the very beginning. All right, I hope this helps. If you've got questions, let me know.